Welcome to the Aurora School for Artists Digital. I'm Christoph, and today I want to guide you through the first steps. For this, we will look at where we find the most important and fundamental functions of the engine, how the most important tools work, and how the engine is fundamentally structured. Then we'll look at how you can create a structure for your project and display the first objects in hand. First of all, we start with Unity Hub. Maybe check again if we have installed the right version with which we want to set up our project. For me, that would be the 2019-14 F1 version, so the latest LTS version that I can download currently. Then we go back to Projects and can create a new project here via the button above. To select the right version here, you can press this little arrow and then select the right version here. So for me, the 2019-14 F1 version. Then we get a window where we can choose various templates. By default, it's set to 3D. In Unity, you can also create 2D projects, and there are various other templates. For example, for other graphics options, I'll leave it on 3D for now. That's the standard selection, and that's enough for us for this first video. And what we're going to do with it, we assign a name for our project. I'll call it First Steps. And next, we can also choose the location for the project. Where do we want to save the project? And there you can simply select a folder accordingly. I'll leave it here for now. And then we need to press Create. And Unity begins to initialize the project. This takes a short moment. And once that's done, we can continue. As soon as Unity has initialized the project, we get the following view of the Unity engine. It may look a bit different for you. For example, the windows you see here might be arranged differently, or you might not see the editor in dark, but in light. You can adjust all that, and it depends partly on the default settings of the respective Unity version, but roughly like now. With me, it should look similar for you. And among other things, you see in the middle here, centrally, the scene view. That's one of the central elements in the editor. And various other windows. We'll go step by step and take a look at each thing one after the other, and delve into various settings and different tools. Where do you find what? What can you do in this editor here? Very central, as I said, the view here. That's basically the area where the scenes or the worlds of the application, everything you want to show later, is placed and arranged. Right now it's completely empty. We have set up a new project. The only two objects that we already see in our scene are a camera, represented by this here, and a light. That would be this sign. Otherwise, the scene is empty. Within this scene, we can navigate back and forth. That's first important to know. And we can, for example, turn back and forth by holding down the right mouse button, and then simply looking around by moving the mouse. Additionally, we can move away from our spot here by holding down the middle mouse button and moving the mouse to navigate accordingly through space. If we, for example, want to move to a certain position towards these two objects, then we simply turn by scrolling the mouse wheel and then zoom into the editor. And then there's the possibility, by pressing the Alt key and pressing the left mouse button, that we can rotate around ourselves. Or, by pressing the right mouse button, we get a seamless zoom and can then zoom in more precisely on objects. To view them in more detail, in the right corner of the view, we then have Eye Control Cross, through which we can quickly reach different views in our editor here, without having to search tediously. This will become clearer once we have a few more objects in the scene. To achieve this, let's first take a look at the hierarchy. In this window titled Hierarchy, here we currently find only a sample scene and nothing more. But when we click on this small arrow, we open, so to speak, the current scene we have loaded. This is the default scene, the sample scene, and this scene contains the two objects, namely a camera and a light. That can be seen here. Within this window here, we can, for example, through a right click, navigate to the 3D Object Hub and add a cube. Then a cube appears in our editor. This can also be done by clicking on the small cross up here, the plus sign. There you get exactly the same overview here of various objects that you can add. Or the whole thing can also be done via Game Object in the bar up here, and then select Cube. I can, for example, add a sphere as well, which is currently hidden in this cube. But it can also be added via this tab, so I said you can reach different views from above via the control cross. And if we, for example, click on this red cone on the X, then we zoom into the side view and we can now view the cube from different sides, for example, also from above. However, it's still perspective. And down here on this rather inconspicuous button, you can switch the whole thing to an orthographic view. That means we no longer have perspective, but the image is rendered orthographically and we can leave this view anytime, for example, by pressing these sides, or by pressing the right mouse button and then rotating, and then we get our scene back here. Just normal from the view we want, but now just from the orthographic view, and not in the perspective view. That means all edges here do not converge on a vanishing point, but remain parallel. If you look, I zoom in a bit more, and I switch now here from the symmetrical view back into the perspective. Then you can see the lines of the cube converging again. Here in the toolbar above, you can find more window settings, with which you can also change the view here. For example, you can switch to see the current image here in the shaded view, meaning all textures and materials are displayed correctly. You can, for example, set it to wireframe, and then you will only see the edges of the objects. Like here, of the cube, the outer edges. And now you can also see inside there is this sphere, which was not visible before, because the textures or the material on the cube were displayed outside. But inside you find the sphere when you just display it through the edges. A few other things are also available. You can, for example, turn off the light, but that's going a bit too far. Let's stick with the basics for now. The sphere here is currently hidden, and it would be nice if we could still see it, even if we have the faces of the cube displayed here. And to achieve that, maybe you have already seen it. There is a transformation tool, and it appears when we click here on one of these objects, or also in the editor here. Simply click on an object and select it. Then a transformation tool appears. Which one it is depends on which one you had selected last. Probably it will be the transformation tool with the arrows, the move tool. With this tool, the object that is currently selected, or maybe there are several selected, then all of them can be moved together, based on these axes that are shown here. And this works as follows. You simply grab one of these axes, and then move the object to the side. If I now move the cube backwards, then you can also see The sphere, which I have not moved, appears accordingly. As you could just see, there are different transformation tools. There is the Move tool, and with it, objects can be moved accordingly. I'll do it again on the sphere. Here, for example, it can be moved backwards. Besides the axes, there is also the possibility to grab two axes at the same time. For that, there are these small areas here in the middle, and then objects can be moved accordingly along the two respective axes. In addition to the Move tool, there is, for example, the Rotation tool. It can be found here in the top left bar. At the moment, this module is selected here in front. And if you want to rotate the object accordingly, then you get the Rotation tool. And then the selected object can be rotated. For the sphere, it doesn't make much sense. So I use the cube for that. If I grab one of these rings along these axes, the object can be rotated accordingly. So, in addition to the Move tool and the Rotation tool, there is definitely the interesting Scale tool, a tool to scale objects, like this cube here. And now again, as with moving, you can scale along different axes. If, for example, you want to stretch the cube in one direction, i.e., lengthen it, then you select an axis and pull it back, and accordingly smaller. You can also scale everything by grabbing this middle white cube to scale the entire object in all directions, making it larger or smaller. As mentioned, this works for all objects. There are one or two other tools. With it, you can enlarge or shrink 2D surfaces, such as buttons, for example. Then there is another tool, which combines all the others. Here you can simultaneously move but also rotate. It is useful if you want to do everything at once. However, there is also the possibility to switch between these tools if you don't want them all displayed simultaneously by using a shortcut. This works by pressing the W key to access the Move tool. Press E for the Rotation tool, and R to scale, which is quite useful to have these shortcuts for quickly switching between the different transformations, and thus being able to adjust the objects in the scene as desired. I already explained that you can also select multiple objects simultaneously, for example, by holding down the Control key and selecting another object, such as both the cube and sphere. When you have selected multiple objects, you can move them simultaneously, but they remain independent of each other. So, I can always go back and select individual objects and transform them accordingly. However, sometimes it may be necessary or desirable to move objects in relation to each other, or to make them dependent on each other. This works as follows. In the hierarchy, in the right view, you can drag an object onto another object, and then you see them subordinate in a hierarchy. This can also be expanded and collapsed. And yes, you see this through this offset. And when you grab this cube here, the parent object, and move it, the other object moves with it, even though it's not selected, because it's subordinate to the cube. This applies to all transformations, for example, also for rotation. In this case, the sphere, which has become a child. Additionally, down here there is a preview, and if I look at it now, from approximately this perspective, then we see these lines here, indicating the edges of the current view area, which is shown here in the camera preview or in the game. And these objects that we see here, correspondingly, the box and the sphere that we placed. And just as the visible objects, here, we can also move the essentially invisible, only represented by the icon, camera. For example, like this, so that our objects are a bit more or closer to the camera. Like this. This also works. This camera view here will then also be ultimately the view that is displayed in the app, or the application that you create with Unity, is shown. So if you were to build an app from this little scene here, then on the screen of a smartphone, for example, this box, and this strange sphere would be displayed all the time. Nothing else would happen. And exactly that would be the section that the users would get to see, just like with viewing. Then there are a few settings up here again, which are quite interesting. For example, to simulate different screen sizes. At the moment it's set to free aspect, which means you see a section here, corresponding to the size of the window, which you can scale larger and smaller, for example, by grabbing this edge. But if you click on it, then you have the option, for example, to view the scene in a 16:9 format. The edges are then grayed out accordingly. You can now see exactly the section that you would see, for example, on a computer screen, if it has a 16:9 format, regardless of the pixel size. Because it adjusts accordingly again, depending on how big I have the window here, and also how big the screen is on which the application will eventually run. I will now add one or two more objects to the scene. For example, a capsule. There is a certain selection of different default objects. Especially interesting, at the beginning are the 3D objects. For example, I will place a cylinder just here, so that they are not quite in the frame. Here, to the side here, that's how they are visible as a set. When we do this, then, here it might still be relatively clear which object is which, but if I now, for example, add just one or two more cubes, Unity automatically numbers them nicely. But it eventually becomes quite confusing. Which cube is which? Where is each one? It becomes chaotic. To avoid this, you can name these objects in the hierarchy. By selecting an object, right-clicking and saying, Rename, then you have the chance to rename this cube accordingly. Or by double-clicking on it slowly. That also leads to the renaming option. Or, if you look on the other side, there is the inspector window. And also the name listed, which corresponds to the selected object. And here too, you can rename the object. I'll do that now. And let's call this one box. But it's enough for demonstration purposes. So now we have the box here. Laying. And if we want to find it again. And now don't know here which cube was the box. Then we see it here in the hierarchy. By the name. Those who have been paying attention might have already noticed. Every time I move an object, you can see in the inspector above that values are changing. This is because the inspector visualizes interesting or relevant data for each object. Every object has various values, for example, for transformation, like position, rotation, and scaling values. And when I move the object, here, for example, on the axis, that gets stored for the object and displayed in the inspector, showing at which y-axis this object is currently placed. And the same applies for rotation, for example. So, if I now move the object on different axes, the values change accordingly. The same goes for scaling. So, if I stretch the object, now in length, the value changes here. Here, the z value changes in this case, and what I can also do, I can directly click into individual fields in the inspector and say no, I don't want this cube to be stretched like this. I want it scaled back to 1 on the z-axis, and accordingly, the scaling here in the editor of this box is adjusted. Now we have pushed this cube to some position and rotated it. And it may be that we now want this cube to be reset to its original position. So, with original, I mean that we want to restore the default values. And we can do that tediously by entering zeros here, for example, in each field. But there's an easier way. I'll undo that now. But we can also achieve this simply by clicking on these 3 small dots at the top edge of the transformed component. We'll get to that in a moment, what a component is. Then just click on Reset. And then the object is placed down here, because this is the origin of the coordinate system. And the rotation is also reset to 0 again, without having to adjust each value here. Now, I just mentioned, this transform here is a component. And essentially, objects are defined by various components. Every object in Unity, in this editor here, has a transform component, meaning every object has a position in this scene, a rotation, a scaling. But some objects, when clicked through, have other components. The added ones are all the same. We always have a mesh filter, a renderer, a collider. What exactly these are, we'll get to that. But if we go to the objects that were there at the start of the scene, like the light and the camera, we see these components are not there. They aren't displayed, for example. Like, we don't see the bodies of the individual objects. That's because they have corresponding components. But the camera, for example, has other components, namely the camera component, which provides settings to adjust the camera, and also provides the functionality to make the camera be a camera. And with the light, it's similar. It has a light component, and again with settings to influence the light, and to enable, for example, a scene to have shadows, lighting, and reflections visible. So, each object in Unity is defined by its components, which provide both its properties and functionalities. I'll show with a simple example how to add functionality to an object. For this, I'll take our box and move it a bit further away from the camera. Let's just check. It's not visible. Already too high. And I'll move the other objects to the side to get a clear view. Back there is our box. Moving this here to the side. And now we have two objects exactly like this. Now we have a view of our cube and the box. I'm now going to give this box a physics component. And here at the bottom of the inspector, there's a button called Add Component. I'm going to search for the rigid body. The rigid body component. And add it by pressing Enter. And now, we see here below, a new component appears, containing settings like mass, etc. We don't need to change that now. We can leave it as it is. What we'll do now is start the application because we have now just added a first functionality to our application, which can become visually noticeable. Starting the application to see how this rigid body component affects the object, namely physically. For that, we need to start the scene, and up here in the middle, there's a button, and when we press it, our program starts. It takes a moment and then we see our cube is no longer there. It has just fallen down. I'll just start again. Watch the cube closely this time. It just falls into the void, physically calculated. This process is handled by this rigid body component, as it provides the necessary function. Interestingly, this functionality that happens here within our game view can be observed not only in the game, but also in our scene. I'll just add the rigid body component to a few more objects here. This will make physics affect all these objects. I'm excluding these three. And when I start again, we will also see here, in this free perspective, without having to look through the camera, that these objects will fall. It'll quickly switch to this game view here. But we can then click back to the scene and see our objects falling into the abyss. That's not very nice. I'll add a ground plane, so these objects won't fall endlessly downwards. So, I right-click or click the plus, and go to 3D Object, select Plane, and move it under these objects, so it's positioned in the shadow, making it work reasonably well. And if I start the scene now, these objects will fall onto this plane. Maybe it's interesting if I tilt this cylinder a bit more and start again. We return and see the cylinder's new position. It's also visible. It behaves correctly, physically, as it tips over, since it can't stand well on that round surface. And yes, it works, even though I haven't given any physics to the ground here. If I click on the plane, I see various components, but no rigid body components, which are responsible for calculating physics. However, all objects I have here currently have a collider, like the ground. Here on the plane, it's a mesh collider. For the box, it's a box collider. And for our sphere here, it has a sphere collider. There are various colliders. And when I click on an object, for example, this sphere, Then I see, using the transform tool, that this sphere has a green indication. The sphere collider. Even though the mesh, what's displayed on the sphere, was deformed, the collider of this sphere remains round. And all other objects, like the cylinder, have the same collider mesh, the same collider calculation as the capsule. Yes, it's due to mathematical calculations that need to happen, and this shape is simply easier to calculate, or performant to calculate. The box here has exactly the edges 200 as colliders shown here. If I want an object, like the ground, to not have a mesh, to not collide with other objects, so they don't land on it when they fall, I can go and disable individual components, and their bifunctionality. So when they fall here, they can't land on it. I can go and turn off individual components, and thus functionality, and that's done using this little check mark, which I can set, for example, on the mesh. If I now start the scene again, then I saw here, the objects have fallen through. They haven't stopped on this surface because it has no collider anymore. And you can do that not only with colliders, but also with the mesh renderer, which is responsible for displaying this object, and turn it off, making the object invisible. The collider is still there. Sometimes that can be useful, but the object is no longer visible. So if I now look, with the camera, at the plane, then this capsule isn't visible. And if I turn it on, then you see it a bit, from this perspective. I can select the camera again, pull it back, and now select this capsule, and turn the component on and off. Then I don't see it. And when I enable it, I see it accordingly. Just like individual components and thus functionality can also disable entire objects. It might be that I don't want this capsule in the scene anymore, or I want to remember it or activate it later. If the user changes something, for example, but I want to keep it, then I can completely disable the object up here. Then it also gets grayed out, and it is neither displayed nor does its physics get calculated, nor does it have any collider. That plays a role in the scene. It might be worth taking a look down here to see what's happening. It could be useful to just take a look below. What all is available as pre-made components, which then correspondingly enables functionality for objects. There's a lot, for example, physics. Also, various colliders are found here. Rigid body, but it can also be used, for example, to simulate wheel colliders and the like. And it happens that one wants to write completely own functionality for objects, or that one wants to make general custom adjustments below this object. Next to these components up here, there's also a material on it. It's currently the default material. It's gray, as currently seen on all objects. But maybe we want to color an object differently. Let's solve this simply now by creating a material. And for that, we need to look at a new window, namely the project window. It's seen down here and gives us an overview of all things that are currently in our project. For example, the scene, the current scene that we have. It's found here in the folder Scenes. If we double-click it, then we see an asset named here, Sample Scene. And that corresponds to the name we also find up here, next to this asset. For the assets can also be created here, for example, the desired material, And for that, I first create new folder or right-click and say Create Folder and name it Materials. I double-click on it to enter the folder. And right-click again, Create, and then look for Material. And I name it, for example, just Red. This creates an asset, a material asset, which accordingly has the name Red. And if we now look to the right in the inspector, we get a whole lot of settings for this material. And among other things, we find here, under the title Main Maps Albedo, a field where you can set a color. If we click on it, we think it's white. Then we get an overview of a color selection. And here we can, for example, choose the color red. And if we do that, then we already see here below, in the material, or also in the preview, that the color of the material has changed. It is now red. And what we can then do is take this asset and simply drag it into the scene. And we immediately see, when we hover this selected material over an object, the object gets colored accordingly with that material. In this case, it turns red. What we can also do, we can hover over the objects. Then they don't color. But if I now drop the selected material on this plane, then the plane gets colored accordingly. I can do that here by just dragging the material onto these objects in the hierarchy or dropping it onto the object in the editor to color it with the material. If I now, for example, click on the material again and change the color here again to a nice blue, then the objects assigned to this material will also change their color to the new one that I set here. If I, for example, change the color here, the objects assigned to this material will change their color to the one I select. If we select an object now, one that we just colored, for example the cylinder, we can also see in the inspector, in the master or in the component, that this material, which is now red or green, is assigned here under Materials. And we can now simply here color another material blue, as explained earlier. And for the sake of clarity, I will make this material red again, called red. Now if we select the cylinder again, we can see in this mesh component, the red material is assigned to this object, but I can change it. I explained earlier, either via drag and drop onto the object, we see immediately it changes here, or via this small dot at the end of this field here, and here we see a listing of all existing materials. There are a few default materials, but also are created materials, blue and red. We have already looked at most of the basics. So we can now insert objects into the scene, move them, rotate them, color them, and know where to find them. Create individual assets like material assets. We know that objects are defined by components, and that the assets here can be assigned to these components. We know where to find more components, and to slowly end this video, I want to touch on some fundamental settings. I mentioned at the beginning that the editor might look a bit different for you. For example, it might not be dark, but light, or that the windows might be arranged differently. To change these settings, I can click on Edit, Preferences up here, and then get an overview of general settings. Here, for example, we find the editor theme, which can be set to light, to get a light visualization. And here, for example, we can also adjust the font, if we want to, and similar other settings. A very interesting thing can be found here under Colors, General, and in the Play Mode tint. And you might have seen earlier, when I start the scene by pressing play here, the entire editor turns green. This is because I have set the color to green here. You can change this as well. For example, I can set it to red. And now the editor turns red. Why is this interesting? It is very important to know that you are in play mode, not only by the blue button at the top but overall, because there are two things that behave differently in play mode than in edit mode. For example, if I close this window, some objects here are positioned differently when I in play mode. For example, this cylinder has fallen to the ground. And thus has a different position than when I am in edit mode. And I might wonder why this cylinder is on the ground. I didn't position it there. And of course, this is caused by the physics component acting on it and making it fall to the ground if I don't realize that I'm in play mode because of the tint, and this component is active. I might think it's a bug. And then there's another thing. If I normally select and move an object here in the editor, I can move it around, but if I leave play mode, the object goes back to its original position. That means this moving I do here, and then I start. The object is shown at its original position. It means it is not saved if I do it in play mode. It jumps back to its position. This has advantages and disadvantages. You need to know that if you move objects in play mode, or change settings in the inspector, these are not saved. But it also means you can experiment in play mode without breaking the whole scene later, or adopting settings that you used only for experimentation. So it's useful to know, just like other settings in the editor, such as the editor's tint or window arrangements. By default, the scene is shown here centrally. The game view is behind it, in the same window. The hierarchy is on the left, and the inspector is on the right. And all of this can be customized. I already showed how to resize the windows, but you can also, for example, take the inspector, grab it by the header here, and move it to another position. I prefer it next to the hierarchy. So when I select an object, I can see its settings right next to it. And for example, you can also place the game view and the scene view side by side. This allows me to see the scene and the camera's perspective at the same time. Without having to switch. That means when I activate play mode, I see the camera's perspective here, and at the same time, I could look at the scene from different perspectives to see, for example, how the physics behave. When you find an arrangement that works for you, you can save this layout by clicking on Save Layout. I'll call it Custom Layout. Then this layout, this arrangement of windows, is saved. And you have a selection of predefined layouts. And you can switch back to your saved layout, or the default layout. Unity offers many more features. Tools, settings, windows, and many other things. But we can't cover everything in this introductory video, so we will stop here and look at other specific features in future videos. I hope this video has helped you and given you an overview of the basics of Unity. I look forward to the next video.